Okay, I'm going back to this example we did in the last class. The salary, the company is offering a 6% raise for those who have less than 20,000 salary. So I wanted to explain that again. I noticed in some of your homework problems, you made a mistake that I want to explain why that's a mistake. So if you look at this, hold on. They're coming in now. Okay, so in this example we did in the last class, uh, some students introduced a new variable to hold the new salary like this. If salary is less than 20,000, then you say new salary, end salary to mean new salary equal to salary plus 6% of salary. And then you say, see out new salary is end salary. So it appears to be correct, but there is a mistake. Anybody see the mistake? This see out new salary, end salary is not inside the if. So if this condition is true, then it'll calculate new salary using this formula. If this condition is not true, there is no new salary calculated. So suppose that the salary is not less than 20,000, then there is no new salary. And this says print the new salary. There is no value in there. So you'll get error message. If you put this inside the if statement by putting curly bracket, if you put curly bracket here, and then another curly bracket to finish. Okay, let's say I put curly bracket here, then I'm moving the cout statement inside the if. 1 second. Now that's not going to take care of the problem because now what happens now is if the salary is less than 20,000, then it'll calculate new salary and then it'll write the new salary. And if the salary is not less than 20,000, it won't write anything. There will be nothing coming up on the screen. Now the user of a computer program will not be happy to see nothing on the screen. There must be something, happening as a result of running the program. So this is not right. User has to see something. So that's why the way, I'll go back to the way I wrote it before, which is eliminate the curly bracket. Now this new salary, change it to salary, and then say salary. So you're using the same variable to store the new salary. No harm done by that. But no matter whether the salary was increased or not, a salary will be written on the screen. So if the salary was not increased, old salary will be written. If the salary is increased, new salary will be written. That's the better way to do it. This will work regardless of uh, whether this condition is true or not. Your program has to work in either case, whether that condition is true or not, program has to produce some result. So keep that in mind. So it's better not to introduce new variable to hold the new salary. Just use the same variable salary to hold the new salary. That's a better way. All right, so that finishes that topic. We wanted to start the logical values. This is where we left off. So let me explain logical values. Logical values would be true and false. We call them logical values or Boolean type values. Uh, we use the word true, false. They will be identified as something other than numbers or characters. So this is another type of value that we can handle in a computer program. And they're called Boolean type values. And there is a data type in C++ called bool to hold a Boolean type value. In other words, if you declare a variable as bool type, then you can store a true or false in it. And it is a common practice to do that in computer programming. To hold the values true and false, we introduce a bool type variable. So now we have learned a new data type called bool. And if you declare a variable as bool, you can store true or false in it. There are only two values. So just like int, float, and char type you learned before, now we have new data type called bool. So here's an example. X equal to 7, y equal to 4. I declare bool type variable w. That means I'm going to store a logical value in w. And then I can write this, w equal to x greater than or equal to y. Now, if this is executed, the system knows that whatever on the right side of this equal sign has to be done first. The equal sign, the assignment is always the last one. The order of precedence will be discussed again in today's class. But what you need to understand is always the assignment will be the last statement. So w equal to will be the last thing it will do. So what is on the right side will be evaluated first. That's an inequality symbol. So x greater than or equal to y will be evaluated. X is 7, y is 4, so x greater than or equal to y is true. So the value of this expression is true. So just like an arithmetic expression, you can have a logical expression like this on the right side of the assignment. And the value of that is a true, and that's what gets stored here, true. And if you see out the w, you will get the word true printed. So it is a value that you can print on the screen if you like. And then I can say if w, that means if w has the true, then see out yes, that's what it means. So a logical value or a Boolean variable can be used in place of the condition in the if statement. It means if w has a true, then do this. So in this case, w has a true, and therefore, what are the outputs on the screen? There will be a value of w, which is true. And then on the same line, it'll write the word yes, because w has a true. So therefore, there will be two things on the screen, true and then yes. Both will be on the screen. That's the output of this program. So let's go on to the.
I have a question. Yeah, so it says if W. So like I thought like I remember in other languages you have to write like if W is true, like equals true. And this one it just says if W. How do you write if false?
Remember the not, we are going to discuss logical not, I think we discussed it already. So yeah, remember exclamation is not in C++. So if I want to say if W is not true, do this, all I need is exclamation point in front of it. This means
Okay, thank you.
if W is not true, then do this, okay? So if you write W equal to true, is that wrong? No, that's correct too. Okay, so many things are correct in C++. There are many ways to write something, but there's no reason to write this true. If you just write W, that means if W is true, then do this. That's the meaning of that. So commonly it's used by programmers. A logical, a Boolean value, a Boolean variable going into if statement is common practice. So if something like this is written in your program in the homework, you have to be able to identify that it is correct, and then you have to understand what it means. Feel free to ask question if you're not following anything. So the Boolean values can be stored in a variable that is declared as bool type. Now let's understand what happens if you convert logical values. If you convert logical values, true and false, the true to integers, you cannot convert them to character. You can technically you can convert them to characters, but then you have no reason to do that. Very often, programmers convert the logical values to integers, so that's a common practice. So I had to explain what happens. If you convert true, you'll get 1. If you convert false, you'll get 0. So you can convert them to integers, store them in integer variables, and then check to see if the variable has 1 or 0, and that will be also correct way to do it. So logical values can be assigned to integer variables. If you do that, then they will be converted to integer value, which will be 1 or 0. All right, so let's see an example. So let me see if you can figure out the value or the output that will be on the screen. When it says write the output, you have to show exactly what will show up on the screen. So as this program, if I execute this as a part of complete, I mean, if I make a complete program out of this and run it, what will be the output?
7's less than 4.
That will be the output. Output means what will be appearing on
No,
the
no, yeah. I understand. I don't think nothing, right? There's no.
0.
nothing will be written. Anybody else? Any other answer?
It would be false. So like, if it got changed into a number, then it would be 0.
It's not. Yes, log is integer, and so there will be some number printed. And what would that be?
0.
Oh, 0. Okay, I see now. All right.
Why is 0? Is it true?
Why
Is
0?
statement is true. M less than n.
Ivan is right. M less than N is true.
Yeah.
Then it would be
Okay.
1.
So log has a 1, and this will print 1. Okay, second question. If the 4 is a 7, then what will be printed?
False.
0. It's not going to print false. We are converting the Boolean value to integer, right? We are not printing Boolean value. Log is not Boolean. Log is int. See that? Log is declared as int. So m less than n is now false. 7 is not less than 7. So the false will be converted to integer, which will be 0. So 0 will be printed now. All right, everybody's good?
Yes.
Okay.
Yeah.
All right, moving on. Here's a little program. I'm writing val1 has 5.3, val2 has 5.3, bool logic, and then logic equal to val1 less than val2. After that, cout logic. So whatever logic has is being printed. Now remember, logic is bool type, not int. And after printing logic, I'm printing int logic, converting the logic to int and printing it. And then it says if logic, then cout yes. Okay, what will be the output? What exactly do you expect to see on the screen? There will be more than one thing.
Zero also?
Logic, okay, What's the first thing you expect? Logic is bool type and it's getting this value, and we are printing logic. What is that going to be?
False.
It's going to be false, and then on the next line, it's going to be a 0.
Right.
Yep.
So it'll print false because of this, and it'll print 0 because of this, right? On the next line. And then will there be any more? Anything else?
No.
Nothing else, because logic is false, so this will not be executed. Okay, so there will be only false followed by 0 on the next line, false and 0. Okay, now the next question is, if the variable val1 changes to 4.3, so this 5.3 now changes to 4.3, then what is the output?
It'll be true 1 and then true.
No, partly right.
What was the question again, Professor? Could you repeat it, please?
I changed the value of val1 to 4.3, from 5.3 to 4.3. Now, what will be the exact output?
Mm.
Now it would be a true, and then on the next line, it would be 1.
Uh-huh.
And then on the next line, it would print yes.
Okay, right. So the numbers, values are correct, but the first value will be on one line. It'll be true. And then on the next line, there'll be a 1, because this is 1. And then on the same line, there'll be yes. Agree with that?
Yeah.
There's no in ENDL after this cout, there's no ENDL here. So therefore, it's going to print the yes on the same line. So the output will be, I'm showing on the board, output will be 1. Oops. 1 second. Okay, on the board. Something going wrong. All right, something went wrong with my pencil. So it'll be a 1 on one line, and then, I'm sorry, true on one line. I had to write with mouse now. True. And then on the next line, there'll be a 1 followed by yes. All this will be the output. All right, anyway, moving on. Okay, warm-up exercise. You need to write a program for this. I need to see you write that. So go ahead and write the program, and either you type it as a message, or show me on the camera, put it against the camera. So I have a chat here. You can write it on the chat or show it to me on the screen.
Do you like this, Professor?
All right. A little bit closer. Okay, I can see that. Right, very good. That's good. Okay, one student got it right. Let me see if anybody else has it. If anybody has a solution, I'd like to see it.
Almost done.
Okay.
Can you reveal the slide again? Just your
Oh.
writing space covers it a little bit.
Sure.
Thank you. I have an answer. Would you like me to share my screen?
Yes, please.
I have an answer too after.
Okay.
Mine's on paper though.
Yeah, that's fine.
I have screen sharing disabled. I'll put it in the chat instead.
Yeah, I have to allow you to share the screen, and I have it disabled because only one at a time can share. So that's not going to work very well. So let me see Anissa's solution first. Okay,
Yeah, I'll get close up for the top and then let me know when you want me to bring it down.
okay. Order and after the C in order, you have something after that. What is that?
That's a P. I made the price just P.
You're not going to get the price from the user. The price is already given to you, right? So only the order has to come from the user, only the number of boxes. Okay, cross out the P.
The C out is, sorry, I was looking at the wrong thing. C
Yeah.
out is how many boxes, like the question.
Okay,
say
how
what
about
box
this?
you have.
And P in order, and you're also putting a P in there. That P should not be there. Cross out that P. That makes it wrong. The CIN statement can only have a variable, one variable next to it. And so order is all you need to get. And then you're saying if order greater than 50, that's no, that's incorrect. You have to first calculate the charge. The rule order greater than 50 needs to be checked only for discount purposes, right? Only to see if the person receives discount. So before the discount, you had to calculate the order, the value of the order, or the charges, amount to be charged.
I really just forgot a line in it.
Okay, so there is that one little problem. And so before the if statement, you need to calculate the charges. All right, there was, I think Alexander said you have a solution
Yeah, my solution is in the chat.
on the chat, okay.
I don't.
All right, so let me open the chat here. Okay, order amount. Okay, it's not wrong. You didn't put the brackets for the else part. You meant to have all of this three statements in the else, and you need brackets if you want all of them in the else part. Besides, the else we haven't discussed. So you can write this without, oh, this is Terence Bob solution. Okay. So I'm talking to Terence Bob. This if else is not necessary, we can do without the else. We don't really need to write so many statements. So I'll explain the better way, but it's not entirely wrong. It's just a longer way to write it. I have Ivan solution, C in number, if number greater than 50. No, it's, you cannot begin with that condition. Number greater than 50. You have to calculate something before that. Let me see. Sherman. Oh, Shimran Bath, right. The boxes. No, Shimran is not quite right either. Okay, I'm reading Alexander's work. Quantity and total equal to right. Alexander has it right. So yeah, so far Alexander's solution is the only one that's perfectly right. So let me copy that and see if I can put it here. See, I'm not able to write much today, so I'm trying to do things in different ways. Uh,
Could you put it in Notepad?
all right, let's try that. That works. I don't use Notepad much.
Sorry, or text edit if you're on a Mac.
Yeah, I know. Okay, there it is. Notes. Okay, let's put it on notes and see if it works. Yeah, okay, that's good. Thank you. So there it is. See, he introduced quantity as the variable to hold the order, that count of number of boxes. Total to hold the total charges. And then ask for the number of boxes entered and read that number. By the way, you don't write ENDL with the CN. There will be nothing. CN statement can only have a variable and nothing else. No ENDL.
Okay.
All right. So CN quantity, that'll read the quantity. Right after that, you had to do this calculation. That's what some of you failed to do. You had to calculate how much the order is worth. So that's just quantity, the order times 550. And then if the order is over 50, then you reduce the total, reduce the order by 10%. Is that 10%? 6%. So let me change this line. He reduced by 10%. So I will write.
Sorry. It's reduced by 10% and then the tax is 6%, I think.
You're right, okay. So he's right, reduced by 10%, but I'm going to write that line slightly differently. Total equal to total minus total times. Times 0.10, which is same as total equal to total times 0.9. That's what he did, Alexander did. So either way is right. So total equal to total minus total time 10%. That's one way. Or total equal to total times 0.9, which means 90% of total goes back to total, which is same as taking 10% off. So so that's the only line he has inside the if. That's the right way. You don't need any more than that. So after that, see, you notice that the variable total has the original bill, and then the total is discounted, but still the same variable is holding the discounted number. And after that, you calculate tax and add it. So it's total times 1.06 means 6% is added to the total to make for the tax. So after that, your total is holding the correct answer, the total value. Now, if there was no discount, still total has the correct order, correct charges. So simply see out total. Now, common mistake is to use a new variable here, like new total, n total equal to this. That's a mistake. That's wrong, because then what do you do here? Do you take 1.06 times n total? Then it's, what if the quantity was not over 50? Then there is no n total, right? So that's the mistake, and many people make that mistake. You have to use the same variable, total, only then it'll work. So this is correct version of the program. If you want to copy that, you can go for it. I'm going to shrink this page, and if necessary, we'll go back to that. I may have to use Notepad today because my pencil is not working. So anyway, let me close that. So that's done. And so that finishes our 3.1. And there will be more homework questions on 3.1. And I'm going to get off of that. and bring up 3.2. 3.2 is if-else statements. Now, some of you used if-else statement in the last homework that was due today. You're not supposed to do that. Never use anything you haven't discussed. Your problem can be done without using anything that we haven't discussed. And that's the way I expect you to do it. And if you use other features, that's not going to be acceptable. So always use everything you learned within the time period. I mean, before that assignment was due.
Professor, will the else statement was used in examples in the 3.1 section?
Yeah, well,
No, I don't think so.
It was in
I'm
the
looking at it
textbook.
right
It
now.
was in the textbook.
It was, yeah. That's why I went ahead of and I was reading everything to do my
Yeah.
homework.
What
Yeah.
in the textbook?
In the textbook
Yes.
right
Yeah,
before
the if else
questions that
statement
you
was in the
assigned.
textbook.
That's
Okay.
how I was able to complete my homework as well.
All right. I didn't realize that would be my mistake. So I don't think I have similar problems anywhere else, but I will. Yeah, I understand. If you used it correctly, I gave you credit in the last assignment. But many students used it incorrectly and ended up getting it wrong. So stick with the things you have learned before that. I mean, I didn't discuss else statement in class, right? So use that fact. The fact that I didn't discuss it means you should not use it. If you use it correctly, that's fine. But most of the time, you don't use it correctly. And 2 students used else statement in the last assignment and they got it wrong. And so that's why I wanted you to stick with what you have learned. So today we're going to learn if-else statements. Basically, it's needed when you need to say, if something is true, then do this, otherwise do something else. That's what it means. So if something is true, I want this to be done, otherwise I want this to be done. You can do that by using if-else statement. So for example, the grade question we asked before. If grade is over 60, see out pass. That means if the grade is more than 60, then say pass. Otherwise, you want to say fail. So now with this if-else statement, you can do that.
Okay. I'm sorry. I'm trying to bundle up. It's a little.
Sam, you have a question or?
Oh, sorry.
All right. So here is how you write the if-else statement. If condition, if, and then parentheses condition, and then statement 1, semicolon right there. So that's where the if statement ends. The if statement ends right here. Right next to it, else statement has to start. Remember, the else statement has to go right next to if, otherwise it's wrong. So when the statement for the if part ends, else has to begin right there. And then statement 2 goes there. If you have more than one statement to write in the if, then you need curly brackets. You can write a whole bunch of them with the curly brackets. You have to begin the bracket and end the bracket before the else, and then else begins. You can have curly bracket here, or if you have only one statement in else part, you don't need the curly bracket. So you only put curly bracket whenever you have more than one. Only if you have one statement in the if, then this format is used. If you have more than one statement in the if, you must use curly brackets, otherwise it will be wrong. So what will happen if I miss this curly bracket and I write this? The error message will be this. The else statement is not paired with any if. That's what the compiler will say. This else statement is not paired with any if. Why? Why did that happen? Because now you don't have the curly bracket, so you have the statement 1 is the only one that's inside the if. If statement can only have one statement if there's no curly bracket. So this is the only statement it'll take with the if. And this statement 2 is outside the if. So it'll execute that as if it is outside. And they execute everything else as if the statement's outside. Then it sees this else. There was no if before that, right? This if was long, that was long time ago. That if only had this one statement. So there is no if that's paired with this else. That's the complaint compiler will give you. So only if you put the curly bracket here, then that entire block is part of the if statement. So therefore, it will recognize else to be paired with this if. That else is now paired with this if. So that's what you had to remember. If you have more than one statement in the if, you must have curly brackets, otherwise it'll fail. Okay, so how's the if statement handled? It'll compute it'll evaluate the condition in the if statement first. That's the first thing. If the condition is true, then it'll do the if block. If block means the statements that are in the if part. If the condition is false, it'll go to the else block and do everything in there. So going back to the previous slide, if the condition here is true, then it'll do all of this. If the condition is false, it'll do all of this. That's the way it does. So one of those two blocks will be done. Okay, so let's see the.
Professor, I have a question.
Yeah.
Is it what would you do if your condition is not met, but you want more, or is that like a more advanced topic? Like you want there to be more conditions, but you don't want there to be like a final else?
You mean you want more than one condition in here? Is that what you mean?
I don't know about more than one condition. I'm saying several different conditions. So several if statements. Could you do something like that?
Oh yes, you can write several if statements. That's coming up.
Oh, okay. Sorry.
It's coming up. All right. So the curly brackets are necessary. I already explained it. If you have more than one statement in either block, you need curly brackets. Otherwise, only one statement will be in the if or else. Wherever you miss the curly bracket, only one statement. And everything you write in the if statement must be indented, like I'm doing, like I did here. See, this whole thing is moved inside by about 3 spaces. And this whole thing is moved inside by about 3 spaces. That's what we call indentation. The indentation is necessary for reading. See, if you don't move it in like that, it'll be too hard to read. When you have it moved in like that, it's so much easier for anyone to read and see which part is in the if and which part is in the else. It's all very clear. So it is required that you do that indentation. Otherwise, you will lose points. I already started grading the last assignment that was due today, and several students didn't indent, and they ended up getting penalized for it. Going on to example, the grade question. We can now do it better. We can write pass or fail. If grade is greater than or equal to 60, see out pass, else see out fail. So only one word will appear on the screen. Either it's pass or fail, depending on whether grade was over 60 or not. Another example is, if I want to do this. If num is 10, then I want to decrement by 5. Otherwise, I want to increment it by 5. Then you can say if num is 10, then num equal to num minus 5. Else num equal to num plus 5, and that'll take care of it. So you're doing only one of the 2 statements will be done. Example 3, write a program that obtains an integer from the user and prints the reciprocal of it. The reciprocal means 1 divided by that number. So if the number is a fraction 3 over 4, then the reciprocal is 4 over 3. If the number is a whole number, like 5, then the reciprocal is 1 over 5. But when if the number is 0, there is no reciprocal. 1 over 0 is undefined. So when you write this program, you need to check to see if the number is 0. So if it is 0, you want to say no reciprocal for this number. Only if it is not 0, you want to find the reciprocal. So here's the program. I'm saying enter the number, I'll find reciprocal, and C and K, read it. And then if K is not 0, then reciprocal is equal to 1 over float K. Notice that I had to write float K because K was declared as integer. So if I do 1 over K, that'll be a 0. So I had to either use 1 point or float K so that the division will be correctly done. Else, that means if K, only if K is not 0, I'm computing reciprocal. Otherwise, I'm putting the message that no reciprocal for 0. Remember, regardless of what happens, you have to tell the user something. You have to produce something on the screen so that user understands what happened. Your program should not be written to produce nothing in any case. Regardless of what happened, something should be there on the screen telling the user what happened. So this program will write either the reciprocal of the number or it'll say there's no reciprocal. So going on to another example, a company wants to give 6% raise to the employees whose current salary is below 20,000 and 4% increase for the others. So this is similar to the one we did before, but this time we're going to give 4% raise to those who don't meet that condition. The condition is salary must be below 20,000. So we can do that with the else statement. So only now we need the else statement. So, okay, I ask for the salary and read the salary. And then if salary is, I made a mistake here, salary, not sal. So if salary is less than 20,000, then incrementing by 6%, else incrementing by 4%. So remember, I'm using the same variable salary to store the new salary. Do not create a new variable. That'll create more problems. So put it in the same variable salary, and then say new salary is salary. So regardless of whether it was 6% increase or 4% increase, the number will be written, the correct number will be written by this cout statement. Okay, a warm-up exercise. All right, I want to see you write this program. You have to do this. You know, if I keep writing myself, you won't learn. You have to do some problems yourself with my help. And so I hope this time more of you will try. This first exercise can be done with 2 if statements or 1 if-else statement. So I want you to write it with 1 if-else statement.
I think I got it.
Okay. All right, I'm looking at Anissa solution.
Sorry.
It's okay, you have it right, except the double quotes around the variables.
Oh, that was an accident. I don't know why.
Right? No double quotes in the variables.
That's
Okay,
good.
so Anissa got it right. Yeah, that's right. Very good. Work on the second one. If you, those who
Okay,
finished
okay.
first one, work on the second.
I'm sorry, for warm-up exercise 1, you wanted us to use 2 if statements
No,
or if else?
if else statement.
Thank you.
I've only seen one student with the warm-up exercise 1. It's not difficult. It's
Some
very
people have it in the chat.
Yeah, I put mine in the chat.
You know?
okay. All right, let me open the chat. Okay, I see Shimran's solution. Maxwell equal to N1. Okay, the way you wrote it, the else is unnecessary. Actually, the else is making it wrong. I'm talking to Shimran Brathwaite. The way you chose to write, you're using the technique we learned in the last class, which is right. You know, there's nothing wrong with that. So if you use that, there's no else statement necessary. So if N2 greater than Maxwell, Maxwell equal to N2, and then this else part should be eliminated. Without the else, you need to say largest number is Maxwell, because regardless of what happened, Maxwell has the Maxwell. And if you say else, then you're saying only if N2 is not bigger than Maxwell, then you're writing. And if N2 is actually greater than Maxwell, you're not writing anything. Okay, so the else is making it wrong. So you need to write the whole program without the else. If you eliminate the else, then it'll be right. Okay, I'm now looking at David Bax, asking for X and Y, and then if X greater than Y, see out X, else, yeah, that's right. That's exactly right. The else should be lining up with if. Remember, when you are indenting, the statement inside if will be indented, but the else will be lining up with if, and then a statement inside the else will be indented. That's how you write that. But David Back's solution is correct. I'm reading Terrence Bob. X, Y, if X greater than Y, see out X, else see out Y. Now, That is correct, but this bracket for the else part is unnecessary. So when there is no need for bracket, don't put bracket in. It makes it harder to read. Other than that, it is correct. Okay, reading Christopher's solution. X less than y, C out y, otherwise C out x. Again, the bracket should be eliminated. It's not wrong, but bracket is necessary only when you have more than one statement. So if you only have one statement, don't write the bracket. It's just confusing to a reader. Okay, I'm reading Ivan's solution. In one,
Apology wrong. I did not use the else statement.
yeah, you wrote it without the else statement. That's fine. This is correct, but I wanted you to write with the else statement. So there are many ways to write it, and so your version is correct. Nothing wrong with it. But we are practicing if-else statement right now. Okay, Alexander Gray has okay, it's correct. Yeah, Alexander, your version is correct, but you don't need to check for equality, because if they are actually equal, then it falls into else part. See, if num1 greater than num2, you're writing num1. You're saying else write num2. So
I see. So it gives a correct answer no matter what.
right. So the else takes care of the.
Okay. Thank you.
Mm-hmm. So I hope everybody understands. So right now I'm looking at Alexander's solution. Let me, yeah, many of you wrote the correct solutions, but I wanted to explain this. So let me copy that and put it on. Okay, so here is, okay, we'll just look at, yeah, David Bax has the right solution too. Let's just look at one of them. Alexander has this statement. Let me enlarge this a little bit. Okay, this equality part, that's what I was commenting about. You don't need that equality check, because if num1 is greater than num2, you're writing num1. Otherwise, the else means if num1 is not greater than num2, that means num1 is less than or equal to num2. Both cases are taken care of in the else part. So if they're equal, then you want to write one of them. They're equal. So either one is, either number is the largest. So therefore, if the number is less or equal to num2, then writing num2 will be good enough, because if they're equal also, num2 is still the maximum. So this is correct, and many of you wrote the correct version, which is good. So I got more participation this time. I like that. So the second one says, write a program that obtains an integer from the user and determines whether it's a multiple of 3 or not. Now, how do you determine whether it's multiple of 3 or not? By, as it says, modulus operator is useful. How do you use modulus operator?
If your input modulus 3 equals 0, then it was perfectly divisible by 3.
Exactly. That's right. If it is a multiple of 3, then it'll be divisible by 3. So you just take the number from the user and see if it is divisible by 3 or not. So how do we write that? So let me write that. I don't want to spend any more time on this, so I'm going to write that part. So we had to ask the user to enter the number. Let me go to my other screen. Oops. Okay, so you need to ask for the number. It's not working properly. I'll just write the key part. You know, you had to ask for the number and then get the number in the variable num. So if num has the value, then what you need next is if num modulus 3, you can check, put that entire condition right there. If num modulus 3 is equal to 0, remember to check for equality to 0, you have to write two equal signs. So if num modulus 3 equal to 0, then see out it is divisible. So you say divisible, and else not divisible. And I have to keep doing this for every part. All right. So that's the key part. You get the number from user, and if num modulus 3 is equal to 0, then divisible, otherwise not divisible. That's all there is for that one. All right, so that finishes 3.2. And so moving on to 3.3. So the homework assignment, I'll put exactly what problems are due on that link. So turn in those problems found on the link. Okay, 3.3 is about nested if statements. We can put several if statements, one inside the other. Sometimes all you need is one if statement with compound condition, many conditions combined, and that's coming up. We will discuss how to combine many conditions. So after that, you will know how to do that. But there are other times, other programming problems in which you need to write if statement inside if statement, many of them. And that's very common situation. So we're going to see how to do that. So we need to, make a series of decisions. We need to say, if this is true, then I want to see if the next one is true. Then if that is also true, then check for something else. So a whole bunch of those. And when they are not true, you want to do something else. So you want to put else also. So you want to write a bunch of ifs and elses. And so then when you write down a whole bunch of those, you have to keep track of which else is going to go with which if and all that stuff. So that's what we need to understand next. So I'm writing as one set of nested if statements here, just to show you a couple of examples. But in real life situation, depending on what you're trying to do, what you have to write may vary from these two structures. So here I'm writing if condition A is true, then another if inside that if. As you can see, I indented it to show that it is inside the first if. If that's true, then it'll be checking this condition. If that's true, then statement 1 will be executed. Notice that I used colors to show you which else is paired with which if. The rule is this: any else is going to be paired with the closest if statement that is not already paired with another if statement, another else statement. So for this else, this is the closest if. and that's the one it pairs with. So these two are together as one if-else statement. And that entire if-else is inside this if, and the else part of that if is this. Notice that I have lined up everything nicely so that a reader can follow easily. This if and this else are lined up, and the statements inside are moved in. And then this red if is lined up with the red else, and everything inside them are moved in. The green if lined up with the green else. These are the pairs. So this if orange one is paired with the orange else, that's the closest pair. And then this red if will be paired with this, because for this else, that red if is the nearest one that is not paired with another else. So that's how it uses, that's how it determines which f goes with that. And this else will be paired with this if, because that's the closest one that is not paired with another else. So that's how they will be paired. And always use indentation so that any reader can follow what's going on.
Just making sure, for example, one, it has to satisfy if condition A, and then if it doesn't satisfy condition B, then it's going to go to statement 3 else.
Exactly.
Okay.
So if the condition B is not true, but condition A is true, that's when it'll do this statement 3. Can somebody tell me when statement 4 will be executed?
If condition A is not true.
Right. If condition A is not true, statement 4 is the only one executed. It won't do anything else. It won't go anywhere else. Only if condition A is true, then it'll come in here and check the condition B. If condition B is not true, it'll do statement 3, and that's it. If condition B is true, then it'll go to condition C. Then if condition C is true, it'll do statement 1, otherwise it'll do statement 2. And that's it. So there'll be only one of these statements will be done. 1, 2, 3, or 4. Now in this other example, if condition A is true, then there is a statement to do, and then check another condition, which we do all the time. If condition A is true, you want to do something and then check for another condition. If that's true, you want to do something else and then check another condition. So that's another example of how the block can go. Then you need curly brackets everywhere. If condition A is true, then statement 1 will be executed, and then condition B is checked. Only if condition B is true, it'll check it'll do the statement 2 and the condition C. If condition B is not true, then it'll do the else for that, which is statement 6.
So, Professor, is basically going through true and false?
Yes, of course.
Okay.
The conditions have to be true to do the statements inside.
What if they're false? Then it goes to the next. It goes to the next statement.
No, if it is false, it goes to the else statement. Else
Okay.
part. Okay.
And you have multiple statements in one condition?
Oh yes, of course. I have the statement 1. In place of statement 1, you can have 5 statements inside. You can have 5 statements and then another if statement.
So if I wanted to output, let's say a word, and then change the value of something in the same statement.
Yes.
I can do that?
Yeah.
Okay.
After that, one statement at a time, you can write many statements right here.
Could you have multiple conditions in one if statement?
Multiple
if condition A and
one
condition
if
B?
Yes, we can have multiple conditions, but that topic is coming up next in the next section.
Okay.
So right now we are writing condition A. In place of condition A, can I write many conditions? I want many things to be true. Yes, and that will be coming up. I don't want
I'm sorry about this. The example number 1 is correct also.
These examples are correct, and they are just examples. In real life, in your real problem, there can be all kinds of complicated ways of writing if statement and else statements. Okay, depending on your need, you have to adjust the whole
In
thing.
example one, it depends by order. It's if I have first condition, a statement, first statement, second condition, second statement, right?
If the condition A is true, only if the condition A is true, you'll go and look at this if and check that condition.
So do you have to tab, or can you just leave it straight on the left-hand side?
For the compiler or for the whole system, that doesn't care. No matter how you write it, it will figure out what it means. But this is the indentation is for the reader. You move in like by a few spaces like that for a reader to see what are the things inside the if and what are the things outside the if. Okay.
Oh, we lose points on like a homework or anything if we don't.
Right. Yes. You lose a small amount of points if you don't follow these rules, indentation rules. That's because you're a beginning programmer. You need to learn to write properly so that others can read your program. And therefore, as an instructor, I have to enforce that. And that's why I have to penalize you if you don't follow those rules. The penalty will be small, but I have to do that. So do this rule, indentation, follow that rule, then it'll be easier to read your program. That's why that rule is there. So as we proceed, we'll be doing examples, and it'll become more clear when we do the examples. All right, so let's see the rule the compiler uses to combine else's with ifs. To pair the else's with if, compiler will use the rule that any else statement will be paired with the nearest if statement that is not already paired with another else. All right, I already mentioned that, and I already explained. So let's go to an example, then you will understand better. The grade. Suppose that there are 3 test grades, and I want to find the average of the grade. And then if the average is over 60, the student will pass. If it is over 70, he will get C and all that. So now I want to write A, B, C, D grades, not just pass and fail. Now with this nested if, we can do that. Now the way I'm writing it right now is one way. This is not the best way, but I wanted to explain to you that you can write it this way. So I get the 3 grades from the user. Ask for the 3 grades, get all 3 of them, find the average grade, and then I'm beginning with 60. You can begin comparing with against 60 or begin by comparing against 90. Either way, you can finish the program. I'm going to finish by starting with 60. If it is over 60, I cannot immediately conclude. I cannot say whether it's pass or A or B or C. No conclusion can be made. So that's why I have to check against 70. If it is over 60, then compare against 70. If that is also true, then compare against 80. If that's also true, then compare against 90. I have to do all that, 4 comparisons. Only if it is over 90, then I can say the grade is A. Now this else is paired with this if, which means only if it is above 80 but not over 90, that's when this will go, it'll go here and execute this else. And we know that the grade is B in that case. It's not over 90, but over 80. That's the case we have here. So it is B. Now this other else is going to be paired with this if. So if grade is not over 80, it'll go here. But we already know it's over 70. So therefore the grade is C. Now this if is paired with this else. So therefore average grade is not over 70, then it'll go here, but we already know it's over 60, so therefore it is D. Now for the first if average grade is not over 60, then it'll go to the else that's paired with that, with this, which is the last else, and it'll write F. So if it is not over 60, grade is F. So this will write the correct grade. But as you can see, you have to pay attention to see which is paired with which, and it is kind of tricky, right? It can be complicated. But the following structure is useful in situation like this, and it is much easier to follow and much easier for you to write also. and it's called Effelsive Structure. And here it is. Effelsive Structure will say, if condition A, then you'll have a statement, and always the next thing is else. You don't write another else, if, okay? Using this structure, you can almost always handle your complicated problem. So for this if, I'm writing else. Instead of this statement, you can have many statements if you like. Then you have to have brackets. That's the only thing. But the next thing you write is else statement, not another if. So I'm saying if condition A is true, then do this statement. Otherwise, check this condition. And if that is true, then do this. Otherwise, check this condition and do that. Otherwise, check another condition. So it's always if, else, if, else, if, else, whole bunch of them. And we write them in this manner. You don't put the if statement in the next line. Instead, you combine that else and the if together, but there must be a space in between. This space is necessary. Other than that, you write the else and the if next to each other so that it becomes so much easier to read. And so only this structure allows, only in this kind of structure, you're allowed to use that else and the if next to each other. This is a special structure in C++ called Effelsive Structure. And this eliminates a lot of the complications and makes things easier in almost all the situations where you had to use Effelsive. You had to use nested if. This becomes useful. So this makes it a lot easier. So I just want to show you the example using that, and then we'll be done. The grade example is now going to be easier with this. You get the 3 grades from the user and find the average grade, and then start by comparing against 90. If it is over 90, see out grade is A, else. The next thing is else if. So that means if it is not over 90, then it'll go here. And now we are checking to see if it is over 80. Then the grade is B. Else if, compare against 70, and the grade is C. Else if, compare against 60, grade is D. Else if, else, there's no if anymore, you're done. If it is not over 60, then we want to write F. So the last one is always just an else without if. And that structure is much easier to follow for a reader, and also much easier for you to write. So I advise you to use this structure when you need nested if structures. All right, so we are out of time, so I'm going to stop here. So I will have the problem numbers that you need to do for this assignment on the link itself. All right, so enjoy the rest of the day. I'll see you Wednesday.
Hi, Professor. This is Tucky.
Bye. Have a nice day.
You received my email that I sent in regards to homework number 8.
You sent an email?
Yes, I sent an email.
Okay, yeah, I'll check that.
Okay, thank you so much.
You're welcome.
Take care.
Bye-bye.
Thank you, bye.